For nearly 80 years, scientists believed the first Americans walked in from the frozen north just 13,000 years ago. But along California's coast, nearly two-thirds of the evidence vanished, swallowed by the Pacific when sea levels rose more than 400 feet. Only the Channel Islands remained, preserving layered clues to a human story thousands of years older than the textbooks allowed. Why did these isolated outcrops hold the key to rewriting America's beginnings? And what does the lost shoreline still hide? At the height of the last ice age, California's coastline stretched miles beyond today's familiar cliffs and beaches. Sea level stood nearly 400 feet lower, exposing a vast plain where rivers met the Pacific and kelp forests fringed the edge of the continent. This ancient shoreline teemed with life, offering rich resources for early people. Yet almost all physical traces of their presence now lie hidden beneath the waves. As the glaciers melted, the ocean rose relentlessly, swallowing up to 65% of the land that once formed California's coastal margin. Entire river valleys, estuaries, and campsites disappeared under hundreds of feet of salt water, erasing the evidence that could have rewritten the story of the continent's first inhabitants. For decades, archaeologists searched the interior, following the logic that the oldest clues would be found inland, where the ground remained dry and accessible. But the true scale of coastal loss went unappreciated. With each meter the sea advanced, the archaeological record shrank, leaving only a thin fringe above the high tide line. On the mainland, what survived was often scattered or deeply buried, out of reach of traditional excavation. The Channel Islands, perched 8 to 20 miles offshore, escaped this fate. Their rocky heights remained above water, preserving a rare archive of human activity while the mainland record vanished. The islands became the last accessible fragments of a world erased by the sea, a world where the first Californians made their homes, gathered food, and left behind the clues that would finally challenge the old migration story. The search for answers shifted offshore toward the only places where time had not washed the evidence away. Archaeological teams began their search on the Channel Islands, just miles off the California coast, where the land had escaped the rising seas that erased so much of the mainland's past. Here, in wind-carved caves and along ancient terraces, they uncovered layers of human life that reached far deeper than anyone expected. Beneath the surface, deposits revealed a story of continuous occupation stretching back as far as 16,000 years ago. Thousands of years before the inland Clovis culture appeared. Hearths, tool-making debris, and food processing areas lay stacked in orderly sequence. Their preservation owed much to the island's isolation during the Ice Age. Stone tools found at these sites told their own story. Many were crafted from chert and other materials traced directly to the mainland, a clear sign of repeated crossings over open water. These journeys required not only the ability to build watercraft, but also the knowledge to navigate shifting currents and tides. The Channel Islands had never been connected to the mainland, even at the lowest sea levels. Anyone who lived here had to arrive by boat, bringing with them the skills, resources, and community needed to thrive on isolated shores. Every artifact, every layer of charcoal challenged the old assumption that the first Americans walked in from the interior. Instead, the evidence pointed to a maritime people, at home on the water, who settled California's coast long before the rest of the continent was peopled. These discoveries demanded careful verification. How old were these sites? And could their age be proven beyond doubt? Each sample was assigned a unique identifier, such as AS02, ensuring a clear record from excavation through analysis. To remove any trace of contamination, the charcoal underwent rigorous chemical pretreatment, stripping away humic acids and other organic intrusions that could skew results. The samples were then analyzed using accelerator mass spectrometry, or AMS, a method capable of measuring the tiny traces of carbon-14 left in ancient material. Identical samples were sent to 3 independent laboratories. Each lab worked blind, unaware of the other's results, applying its own protocols and calibrating against international standards. The results arrived in close succession. All 3 labs returned radiocarbon dates that clustered tightly between 13,000 and 16,000 years before present, with error margins of less than 150 years. Statistical comparison confirmed that the dates overlapped within a single range, eliminating the possibility of laboratory error or random chance. This triple lab consensus left little room for doubt. The Channel Islands sites were occupied thousands of years before the Clovis culture appeared inland. For the first time, the timeline was locked in place by independent scientific confirmation, shifting the focus from speculation to established fact. Isotopic analysis revealed striking results. Island remains showed delta superscript 1 superscript 3c values near -20 per thousand and delta superscript 1n values around +12 per thousand, numbers consistent with a diet sourced almost entirely from the sea. Analysis indicated that roughly 80% of the protein consumed by these early Californians came from marine resources, fish, shellfish, and sea mammals drawn from the kelp forests surrounding the islands. These kelp forests, stretching from Alaska to Baja California, formed a continuous green corridor along the Pacific coast. Marine biologists rank them among the most productive ecosystems on Earth, supporting dense populations of edible species year-round. For ancient voyagers, this meant a reliable food supply at every stop, in stark contrast to the unpredictable resources of the interior. The archaeological record on the islands supports this picture: middens packed with shells, bones of sea otters and seals, and tools designed for fishing and processing marine plants. Multi-beam sonar swept across the seafloor west of the Channel Islands, tracing long parallel ridges that once formed ice-age beaches. These ancient shorelines, now lying up to 200 kilometers offshore and beneath more than 120 meters of water, revealed the lost edge of California's continent. Sediment cores pulled from these submerged terraces exposed layers of sand and gravel shaped by waves when the land stood dry. Within these deposits, marine geophysicists identified pockets of blackened soil and clusters of fractured stone flakes, debris left by toolmakers working at the water's edge more than 15,000 years ago. The shapes of these microliths match styles found on the islands above, confirming a direct link between the submerged plain and the earliest coastal camps. For the first time, the archaeological record extended offshore, preserved in the silence beneath the Pacific and mapped with the precision of modern technology. Genetic analysis of the Arlington Springs remains provided the final piece of the puzzle. The results revealed a clear affinity between the Channel Islands' individual and founding populations that entered the continent along the Pacific coast, not through the interior. Patterns of shared genetic markers showed movement from west to east, matching the archaeological evidence that people settled California's coast before spreading inland. Crucially, the timing of this genetic dispersal predates the opening of the ice-free corridor, which did not become passable until around 13,500 years ago. The DNA confirmed what radiocarbon dates, stratigraphy, and maritime artifacts had long suggested. The first Americans traveled by boat along California's kelp-rich shores, establishing coastal communities long before the Clovis culture appeared in the heart of the continent. Today, every new find beneath California's waves reshapes what we know about human origins in the Americas. As underwater archaeology advances, the Pacific still guards secrets older than Clovis. California's coast reminds us that history isn't set in stone, it's waiting just beneath the surface.